All right, so this lesson's on radicals and square roots. And those terms are somewhat interchangeable, but the symbol itself is called a radical. When it's being used to square root, we call this a square root. Now, let's just talk about what a square root is. 2 is a square root, and it's equal to root 4. So that's a square root. This is a square root. What makes 2 a square root? Well, a square root is a number that when multiplied by itself gives you the number under the radical. So 2 is the square root of 4. 3 is the square root of 9. So the square root of 9 is a square root, but notice again, these are equal. So 3 is a square root, root 9 is a square root, but 3 is the root of 9. The radical part is just the symbol. Okay. So here you say, what is a radical? A radical is just that operation sign. It's this. That's a radical. And it tells you what to do to a number and expression based on what's called the index. Okay, and a radical is often called a root. Sometimes there's square roots, sometimes there's cube roots, sometimes there's fourth roots, right? The number or the index can change. The type of root can change. So it's this number here on the outside that's called the index. This symbol is the radical. And the number that's on the inside of the radical is called the radicand. Now when we take a square root, we don't write a 2 here, because the square root's the most common. So we don't write the 2. But if it's a cube root, the index is 3. It's the type of root. Okay, and we'll see an example of this in a moment. Now if the index, like I said, if the index isn't written, then it's automatically a 2. And this is just a helpful hint. We're not having a lesson on this, but for some of you, you might find this helpful. A radical is just a way of writing fractional or rational exponents. Exponents that are fractions. Okay? So remember, this is the square root of x to the first power. Well, written with fractional or rational exponents, that's x to the half power. The cube root of x. Well, this is cube root of x to the first power, so this is x to the 1/3. Right, so 1/3 of the way to x in a multiplication kind of way. This is the cube root of x squared, so this is 2/3 of the way to x in a multiplication kind of way. So when we have something like root 9, you can think of this with fractional exponents, okay? Why a root and 9 just cancel out with each other. Or they don't cancel out, but why root 9 makes 3. Think about this. If we write 9 as 3 squared, and we write the radical as a half, we get 3 squared to the half power. And when we have a power to a power, you multiply. So you get 2 over 2, which is 1. So you get 3. So this is why a square root and a square, or a cube root and a cube, undo each other. Okay, that's kind of a big idea. All right, next. There's 3 main properties of radicals. And one is, if both numbers are in the inside, you can separate. Or vice versa. If you have both numbers on the inside, you can multiply. Okay, so in other words, we can factor these or separate them into their parts. The cube root of AB is the cube root of A times the cube root of B. So the square root of 27, this is what we've done. We've simplified radicals. You can separate root 27 into root 9 times root 3. And we could take the square root of just this factor, 3 root 3. Okay, the cube root of 24, we can separate. And you think, well, what is a cubic factor of 24? Well, we got 8 and 3. 8 is a cube. It's a perfect cube. I can explain why real quick. If you had a cube that was a 2 by 2 by 2, what would the volume be? Length times width times height. 2 by 2 by 2, or 2 cubed, is 8. That's why we call this a cube, because it makes a cube. So the cube root of 8 is 2. The cube root of 3 is still just 3. So our final answer is 2 cube root 3. All right, so we have our product property. We can separate or we can multiply. Same idea with our quotient. We can separate or we can divide. So if you have the root of a over b, you can just separate it into root a over root b. Doesn't matter, and I only have this as just an added example. Like it works for all roots. You can have this as the cube root of a over the cube root of b. The only condition is what can b not be. What's the one thing it can't be on the bottom? 0. Can't divide by 0. So if you had to square root 9/5, you could do this in parts. You could square root the 9, and then you could square root the 5. And so you'd have 3 over root 5. You could take the cube root of 8/27, cube root the 8, cube root the 27. 8 and 27 are both perfect cubes. So the cube root of 8 is 2, the cube root of 27 is 3. Okay, and the last property is what's called the power property. It's just a convenient way of kind of rewriting things. This is the nth root of a to the b. Well, that b right now is on the a, but you can actually make the b. It's the same thing as putting the b outside and saying I'm going to find the nth root of a and then raise it to b. So if you had to find a cube root of 8 squared, cube root of 8 squared, that means the cube root of 64. Maybe you don't know the cube root of 64. Well, what you can do is you can rewrite this as the cube root of 8, and then that answer squared. So in other words, like we've already set up here, the cube root of 8 is 2. So we have the cube root of 8 is 2, 2 squared is 4. So it's just a way of rewriting things, sometimes making it more convenient. Okay, so some of you have asked, how do you know if your answer is simplified? Well, these are kind of the conditions. A radical is going to be simplified, or in its simplest form, if no radicands, nothing under the radical sign is made of perfect squares, cubes, or factors other than 1. Or perfect square factors other than 1. And then no radicand contains fractions. You shouldn't have a fraction inside the radical. And all like radicals have been combined. We'll do some examples. Now, these are the steps for simplifying. We've done this in class. I just wrote it out in words so you'd have it there. Now, the only difference is we're going to simplify a radical if it's got a cube root instead of a square. And we're going to do one with a variable. Okay, it's the same procedure that we did in class. If we're going to take the cube root of 40, the first thing we're going to do is we're going to factor 40 into its parts. Like make a factor tree. 40 is 2 times what? 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So the prime factorization of 40, notice we have our 4 branches there. We have 2 times 2 times 2 times 5. The x to the 5th, we can factor that easily. It's just 5 x's. Now, because our index is 3, we need to circle groups of 3. Well, there's a group of 3 2's. There's a group of 3 x's. A group of 3 is a perfect cube, so this is actually 8. 2 times 2 times 2 is 8, and the cube root of 8 is 2. So this group, the 2 will come out, and with this group, a 2. And with these 3 x's, an x will come out. So we have 2x times the cube root of what's left? 5x squared. Okay, so write the prime factorization. And in this case, because our index is 3, we circle groups of 3. Anything that's not circled stays under. Everything that is circled comes out. All right, so you now simplify the cube root of 72x to the 8th. All right, this next part is what's called rationalizing the denominator. Rational implies fraction. A radical is not rational. It cannot be written as a fraction. And so the idea is, right now, first it means to write the radical expression so that the denominator doesn't have a radical in it. So we're going to take something that looks like this and turn it into something that looks like that. Notice root 2 is on the bottom. Now positive 2 is on the bottom. Positive 2 is rational. So we're just going to make it so the radical is never in the bottom. This is simplified, that's not. Okay, and we did that here. Like, this is not simplified yet. We really should take that a step further, but we didn't learn it yet. It's all right. It's not too hard of a process, though. So let me just explain. Basically 2 steps. To get rid of the radical in the denominator, multiply the numerator and the denominator, both top and bottom, by whatever radical is showing up in the denominator, and then you just simplify. So if we have 2 over root 3, what can we multiply root 3 by so that the square roots will cancel out? Well, we multiply by itself. Top and bottom by the same thing. Just keep in mind, you don't have to circle this, but what's root 3 divided by root 3? What's anything divided by itself? All of that is equal to 1. We're just multiplying the fraction by 1. That's why this is allowed. But now we just simplify. So we multiply straight across. 2 times root 3 is 2 root 3. Root 3 times root 3. Use our product property. Root 3 times root 3 is root 9. Now simplify. We have 2 root 3 over 3. So the radical was in the denominator. We did a little bit of our math. It's no longer there. Okay, so we have root 5 sevenths. Well, we can use our quotient property if we want and separate this, root 5 over root 7. And now we're going to multiply the top and bottom by whatever radical is in the bottom, which is root 7. Top, bottom. Now multiply. Now we haven't actually got to the practice multiplying yet. That's on the next page. But when they're both inside, you can multiply. Root 5 times root 7, that's our product property. Root 35. Root 7 times root 7 will be root 49. So our final answer, root 35 over 7. Square root of 49 is 7. Okay, C. This time the denominator has not just a radical, but has a non-radical or rational number in the bottom. The process doesn't change. We still multiply the top and bottom by whatever radicals in the denominator. Okay, now go straight across. 8 times root 2 is 8 root 2. 3 root 2 times root 2 is 3 root 4. And the whole point is root 4 is 2. So our final answer is 8 root 2 over, well, 3 times 2 is 6. And I suppose it's not our final answer. Why? The numbers outside can be simplified. Right? That 8, 6 isn't simplified. So we can write this as 4 root 2 over 3. 8, 6 is 4/3. All right. Lastly, I just wanted to give you an example of this. Like root 3 over root 6, using our quotient property, is the same thing as 3/6, which is the same thing as 1/2. Okay, so really this is root 1 over root 2. And then we'll multiply the top and bottom by root 2. Okay, root 1 times root 2 is root 2. Root 2 times root 2, the whole point is that the roots will cancel out. So root 2 times root 2 is 2. Okay, if any of that, obviously maybe watch it again. It's called rationalizing the denominator. So if my explanation didn't make sense, search that and you can see more examples. But rationalize the denominator on both of those. All right, so now the last two things are just how to multiply with radicals and how to divide. And we've already practice it a little bit, but this will just give you hopefully a clear understanding how it works. You can multiply radicals if they have the same index. Oh, my computer went to sleep. Hopefully you're still there. All right, so the steps for multiplying the radicals: multiply all the numbers that are outside, multiply all the numbers that are inside, and then just simplify. Okay, so I've kind of led you through a bunch of examples here, and they're real simple. 2 and 5 are both outside, so we can multiply them. The 2's outside, the root 5's inside, so you can't. It just stays 2 root 5. Now the 2's inside and the 5's outside. You still can't multiply them, or at least join them up. You can write them next to each other, 5 times root 2. In D, they're both inside, which you can multiply the numbers that are inside, so we get root 10. Here we have numbers outside and only one thing inside, so we multiply the numbers that are outside, 10. Root 3 doesn't get multiplied with anything. Here we have one number outside and 2 inside, so we multiply the numbers on the outside, 2, multiply the numbers on the inside, 15. Okay, and then G, it's just all of it, right? We have 2 numbers outside, 2 numbers inside. Multiply the ones outside, multiply the ones inside. And that's it. Now, if root 15, if this came out to be something like root 20, you would still simplify that, because root 20 has a perfect square factor. Root 15 doesn't have a perfect square factor, so it's fully simplified. All right, so your turn. Just multiply these, and then simplify when you're done. Now, I know we didn't do an example like this, but this is just the distributed property. Okay, so distribute on that one. All right, lastly, dividing radicals. And this is just kind of like the simplest version. Right? And this we're not really having a unit on radicals, just so we can use them in our operations. We can only divide radicals, just like multiplying, if they have the same index. Okay, so now they're both outside. So 6 divided by 3 is 2. They're both inside. Root 6 divided by root 2 is 3. One's in, one's out. You can't do anything. These two are out. You can divide them. 6. There's nothing left with that, so you leave it. 12's outside, and there's nothing to divide it with, so it stays. Root 6 divided by root 2. Divide it. And then lastly, we've got 2 numbers out, 2 numbers in. Well, the 2 numbers out we divide, and in this case, 3 halves just stays 3 halves. Root 20 divided by root 4 is root 5, and that's root 5 on top. The 4 goes into the 20, so don't get confused and write that root 5 on bottom. So the final answer is just 3 root 5 over 2. All right, so there's a few you-do questions. In class, we'll do a little bit more challenging questions, but now just the basics. So divide these, and that's it. If you do have any questions, just feel free to write me, though, if you do.